Hello everyone, my name is Austin Rovinsky, and I'm an assistant professor at New York University. This is the 8th lecture in my mini-course on physical design databases, and this lecture will focus on building the OpenROAD application. For those of you who are new to large-scale software projects, you should know that compiling them isn't always the easiest. In OpenROAD, there are two important steps. One is to build the dependencies, and the other is to actually compile the application. In OpenROAD, we've tried to make this process as simple as possible by providing scripts to do this with minimal effort. I want to take a moment here, however, and point out that there are two different build processes for OpenROAD. One is to build just the application itself. This is useful if you only want to use the built-in test suite, which mostly has just the unit tests and maybe a few flow tests. Or if you want to use OpenROAD with third-party design flow. The other, more common option is to build OpenROAD flow scripts, which will install OpenROAD during this process. This is very useful because OpenROAD flow scripts has to be linked to the correct version of OpenROAD to work properly. I will demonstrate how to do each of these builds. Before that, I just want to highlight that these build infrastructures, the instructions for these builds, rather, are online. And this should probably be your preferred source on how to build each. As a developer, the best option for installing the tools is going to be using the local installation, which will natively install the flow and/or application on your machine. Using Docker and pre-built binaries is not the most recommended option. If you are a Windows user, then using the Windows subsystem for Linux is the recommended method. All right, so I have my terminal pulled up, as you can see here. This is generally my preferred way to operate OpenROAD and to develop all of these. So the first thing that you're going to want to do is, if you go to the OpenROAD website, specifically the GitHub for the OpenROAD repository, you'll find a link where you can use Git to clone your repository as a fresh copy on your machine. If you're not familiar with how to use Git, it's not super difficult, at least for the purposes that we have. But you might want to take a moment to look up a guide on doing some basic operations with Git, such as cloning, such as possibly adding, committing, things like that. So we'll go ahead and start cloning OpenROAD. OpenROAD unfortunately is a little bit hefty, so this clone time could take a little bit of time. And it is a few gigabytes at some points, but we'll get back and resume this once it's finished cloning. Okay, so we've finished cloning here, and we can see that now we have an OpenROAD repository in our current directory. So we'll navigate into that. And just to give you a quick preview of everything that's in here, there's going to be the build system in here. Here's the cmake lists.txt. There's going to be the source folders, test folders, all sorts of things in there. So the thing that we're going to be most concerned with to start is the dependency installer. This is going to be located in the etc folder. So we'll just navigate there really quick. And there's also a few other useful helper scripts. Many of these are actually used for the continuous integration that OpenROAD performs. But this dependency installer specifically is going to be what's used to be the most straightforward way to install the dependencies that are needed to work with OpenROAD. So we'll just navigate back down here, and then the easiest way to do this is going to be running as root using the sudo command. This will make sure that it is installing all of your dependencies to your /user/local folder. If you do not have root access, you can also specify the folder that the dependency installer will install to. So I'll go ahead and run the dependency installer. And you can see it's going to start automatically installing a bunch of things. It's going to check packages if you have an appropriate package manager for a supported system. It will start building some of these tools from source and installing them. It will make sure that all of the versions that you need are up to date and correct. And we'll come back after this is finished. All right, and our build has finished. Just as a quick note, although this is unlikely, some users sometimes see that the build gets interrupted with perhaps a kill 9 signal. And this can be because the dependency installer script by default uses all cores on your machine in order to build all of the dependencies. So even though it's not very likely, at least in this point, if you do see that, you may try just simply rebuilding again, because it tends to be a memory issue that can simply be worked out by retrying. But if you encounter other build issues, you may want to look on the GitHub repository, those issues and discussions, to see if maybe your issue is mentioned there. Okay, so now we're back, and after our build has finished, one thing to make sure is that this repository has Git submodules, which are necessary in case it hasn't already been cloned. So what you can do is do git submodule init, and then you can see that there were submodules that were initialized there, and then git submodule update. And so basically here, the OpenROAD repository is linked to another repository, which in this case you can see are called STA and ABC. So this essentially brings in additional pieces of code so that when you're actually building OpenROAD, that it can make sure that it has all of the code. So now we will go ahead and move on to the build, where first thing we want to do is create a build folder just right at this spot, so we can see that build folder exists now. And we'll navigate to that build folder. And what we're going to do here is we're going to use the CMake build system. So OpenROAD uses CMake as a means of orchestrating all of this software build. Essentially how CMake works is it will generate a make file, a GNU make file, which you may be familiar with. It's one of the oldest build systems that's still in use, and it will automatically detect the dependencies and targets of the software and then ultimately build everything that needs to automatically. So the way to do this is we will do cmake ... which is a reference to one step down the source folder, a whole bunch of configuration, and you'll see that build files have been written to, and then the location. So now that that's done, you can see that there's a bunch of auto-generated files, and the only thing we need to do here now is just do make, and then in order to speed this up, I'm going to add this -j option, which specifies the number of jobs or number of threads to run with, and I'm going to pick a comfortable number for me, like 8, to make sure that it doesn't get too overwhelmed. This is another case where if you have too many threads running at the same time, then you might see that your build gets killed. So this can definitely take some time. On slower systems, it could take up to an hour, but at least the whole thing should complete automatically. There's a lot of components here, and you'll be able to watch it as it's scrolling through, and hopefully it has a percentage indicator, which doesn't indicate time necessarily, but it does indicate number of files that have been built so far. So we'll let this run for a bit and come back when it's all complete. Okay, so our build has finally finished here. You'll see that the important thing right here is that right at the end it's built target OpenROAD. So that means that it built the OpenROAD binary. The next step is to technically install it, so these binaries are not in a convenient location. So we're going to want to run make install. But before I run this. The important thing to note is that the default location is going to be in a /user/local, so you would need sudo in order to install it there. Generally, this isn't the most recommended option because OpenROAD updates very frequently, and you'll want to be able to more easily modify this location. So one thing you can do is to set where the install location is going to be. And so at least make has, the way that's generated by CMake, it has a default variable called prefix, which lets you set where the install directory is going to be. So here we're actually just going to make a folder called, actually let's make it one level up and let's call it just bin. Or rather, it will create that folder, so let's call it OpenROAD. Just something like that, some name that's easy to see. So we'll do that. It'll run a few things. Okay, so made a small mistake there. The prefix keyword is if you're using that with CMake, but if you're using it directly with the makefile, then it's actually this dest_dir variable. So if we run that, then hopefully this time it should work, and it does. So we'll see that it's installed all of these to the prefix directory that we gave. So it's one directory down from here, which is this build folder, and then installs it to this OpenROAD bin. And then, well, it adds sort of this /user/local, which was sort of the default included by CMake. But then otherwise, the rest of the files are going to be at that location. So we'll just go ahead and navigate there, go to the OpenROAD bin directory that we just created. And then here, we'll see that there's the bin, there's the include, and there's the lib folders, which if you've worked with Linux installs before, then this looks quite normal to you. So the binaries that we're interested in are going to be in this bin folder. And we can see that there's OpenROAD. It does also make a separate STA executable, but we can go ahead and run this OpenROAD, and now we're at the OpenROAD prompt. So one other thing to note is that if you'd like to run some tests to make sure that your install is correct, you can navigate back to the build folder, and you can actually just run make test. And this uses the built-in test system to start running the OpenROAD unit tests to make sure that everything compiled correctly on your system, and it will show you if any tests are passing or failing. So there's a lot of them. You might want to actually run this in parallel. I believe it should work in parallel. That's using, again, that -J and then a number option. So we'll let this finish up. Next, we'll look at the preferred way to sort of interface with OpenROAD, which is installing OpenROAD flow scripts. So as I mentioned before, OpenROAD flow scripts by default installs OpenROAD as well as the other surrounding tools that are needed in order to run the entire OpenROAD flow. So this is the preferred method because not only do you get OpenROAD, but you also get the full flow testing capability, because the OpenROAD application by itself doesn't necessarily have the same degree of integration testing that is available with OpenROAD flow scripts. So with OpenROAD flow scripts being installed, you get both the unit tests and small flow tests that are inside OpenROAD, as well as these larger scale tests, and just generally nicer working environment if you're planning on building or testing designs with OpenROAD flow scripts. So here, we're going to go ahead and start by going to the OpenROAD project GitHub, and you can find the link to clone, which is going to be here. So we'll go ahead and clone from this repository. And this one is unfortunately, because it includes OpenROAD, going to take even a little bit longer. There's lots of design data that's also in here, which tends to take up more disk space than just having the application by itself in those source files. So we'll let this finish and then come back when it's done. All right, so that finished up. So now we can navigate, or we have navigated inside of our OpenROAD flow scripts directory. We can just take a look and see what's here. So the first thing that we need to do here is make sure that we install our dependencies. This is slightly different because OpenROAD flow scripts has its own dependency installer, which is on top of the dependency installer that needs to be run from OpenROAD. So there is a convenient setup script here. So if you take a look inside, it's not really much, but what it does do is you'll see that it does first install the dependency installer from the OpenROAD application, and then it does the install script, the dependency installer script from OpenROAD flow. So we'll just go ahead and run that. This method, unfortunately, has to be run with sudo, I believe, but if you cannot run with root access or with sudo access, then you can just run those steps individually. So we'll go ahead and do this /setup. And this will, again, start running through the dependency installer. You can see that's running through the same installer that we had before for OpenROAD, but then it's also going to install some dependencies that are specific for just the OpenROAD flow, which actually Klayout, you may have seen there for a second, was. So we'll come back when this is finished. All right, so the dependency installer has finished up. So the next step is to just simply build OpenROAD. And there's also a very nice build OpenROAD script that's here in order to help with that. So I actually just want to quickly show that this has several options in case you need to do something advanced. I believe it should just be --help. Yes, so this brings up the help menu. It tells you about all of the different options that you can use in order to install this. One thing that we're going to definitely want to use is this --local flag. One thing about the installer script is that if it detects that you have Docker installed, it's going to default to a Docker build. As a developer and modifying OpenROAD, it's less convenient to work through that system, so we're going to prefer to do a local build. Then there's some other things in here. Sometimes if you want to build on the absolute latest version of the OpenROAD application, because I mentioned before that the flow scripts is tied to the correct version of OpenROAD to make sure that they both work. But sometimes if you want to work with something that might not have been tested to work yet, you can use that flag. And then you can pass in options to some of the different builds. This one also has the --threads option, so you can reduce the number of threads if you find that your build is crashing, which could be because of being out of memory. And it has some options to perhaps rebuild or install to a specific path. So with that, we can simply do build openroad.sh. Here, it's not necessary to do sudo unless you're planning on doing a install to /user/local or some other system directory. Generally, this isn't recommended because, again, OpenROAD gets updated rather frequently, so you typically have to rebuild over and over. And this will instead install to a local location in here. So as you can see, it detected that Docker was installed and that caused a problem. So I'm going to go ahead and add that --local flag and then get it to actually build. So you'll see it runs the CMake and then it automatically starts building. And then it's actually already finished. Spoiler alert, this is a pre-baked copy because, again, building OpenROAD and building ABC is going to take some time. So for the purposes of time, this is already done. So you can see that it's installed, and this is actually installed to a very specific directory. So if you want to check out where that got installed, we can go to Tools, we can go to Install, and then we can see that OpenROAD and Yosis were both installed at this location. There is also the K-Layout tool. The K-Layout tool actually is installed through the system installer. So it's not installed from source because it has a lot of dependencies and other things that make it difficult to do that. You could install K-Layout from source on your own if that's what you want to, but the dependency installer will just install the packaged version, which is good enough for our purposes. So if we wanted to look inside OpenROAD, for example, we'd see the same bin include lib that we saw before. And then here we have our OpenROAD executable. So we don't need to run it directly through here, although if you wanted to run it really quickly to get to the OpenROAD prompt to see that it works, that's fine. But what we're actually going to do is go into this flow folder, and then from here you'll see that there's a make file, and there's a very simple test that's already built in for this flow, and you can simply run make, and it will run the default design with the default technology, and hopefully it will run through the entire flow. And if it does, and you can see at the end something about GDS, then that means that it was able to complete correctly. So this example design is actually already almost done. And yeah, so we can see that, yeah, right here, this is probably the most important thing. Writing out GDS, OAS, and actually this .gds file, that's your completed chip when it runs through the entire flow. And then also, hopefully, we have some elapsed timing statistics, memory statistics for this flow. So that's it. That's building OpenROAD. So if you were to make any changes to it and then wanted to rebuild it, this is how you would go about it. So that's all for this time. Thank you very much for watching. And thank you again to NordTech, who has funded this series to make it possible. Thank you for being a viewer, and I'll see you next time.